Next session will start at 1 minute. And the session title is changed from the print material. And please check the website for the up-to-date information. Next session is titled Telemetry Global about telemetry and by Lily Chat, Mapbox.
Hello. Good afternoon, everyone. My name's Lily, and I'm on the telemetry team at Mapbox. Today, I'll be presenting some of the work that we're doing at Mapbox with telemetry data to help improve OSM and also expand the use cases of OSM. And here's an overview of my presentation. I'll first explain what is telemetry data and how we handle it at Mapbox. Next, I'll show some of the information we can calculate from this data and how we apply these to enhance OSM. And then I'll dive into one particular example, which is traffic, and show how we create a realistic navigation system using OSM, telemetry, and an open source routing engine, OSRM. So telemetry data is any data that is collected from a remote device. And at Mapbox, we're primarily interested in GPS data. Any device with a clock and a GPS sensor can transmit location updates to our telemetry pipeline. And these data comes in many batches. Each datum consists of a latitude, a longitude, and a timestamp. And we also refer to these as location probes. And here on the right is a visualization of location probes. Now, we can also sort the probes by timestamp and chain them up into a trace. And here's the same data as the previous slide, but visualized as traces. A trace can contain information about the person. Everyone has his or her repetitive daily routines, and the collection of origins and destinations that makes up one's day is like a fingerprint to the person. And at Mapbox, we're not interested in knowing individuals' activity. What we're curious about is the flow of people, the aggregated flow of people. And so we take extensive measure to anonymize these traces so that no one can take a trace and tie it back to a specific person. And how we do this is, when a trace enters our pipeline, the first thing we do is delete any metadata that comes with the trace, and we strip away the origin and destination. And next, we cut the trace up into smaller pieces, and then mix the pieces of traces up with other pieces from the same Z7 geographical area. And just to give you an idea, a Z7 tile is roughly from Kobe to Nagano City in Japan. At Mapbox, we take privacy very seriously. We only store these fully anonymized pieces of traces. And as soon as data enters our pipeline, it's being encrypted following industry's best practice. And that's all the way to including any information we derive from this data. We have very clear boundaries as to who has access to this data and for what reason, and we keep track of who touched the data. And I recommend you to check out our website for more information on how we think about privacy and our privacy policy. So back to probes and traces. From a trace, we can get other information such as bearing or the direction of travel. Here on the right is a map of tadpole-looking things. Each tadpole is the centroid of a Z22 tile, and the direction the tadpole is swimming in is the average bearing of all the traces that pass over the tile. We can also compute speed by taking the distance between two location probes and divide it by the time elapsed. And here's a map of speeds. Each dot is the midpoint between two location probes, and the brighter the color, the faster speed. And we also call these the speed probes. Now we can repeat the process and take the difference between two speed probes and divide it by the time elapsed to get acceleration. And here's a map of acceleration. The warmer the color, the faster acceleration. The colder the color, the faster the deceleration. All these information have different use cases. We use probe density to detect missing streets, such as this one in Puerto Rico. The red line is composed of Z23 tiles where we have telemetry data, but couldn't find a corresponding street in OpenStreetMap. We also use probe density to align satellite imagery. And here are two examples where the streets in OpenStreetMap and the streets in the imagery are misaligned. And by using telemetry data as the third source, we can identify which one is wrong. And in this case, it's the imagery that has an offset. And so we can be proactive about detecting the offset in our imagery by comparing the imagery to a raster or a picture of telemetry density. And now, I won't go into detail of this, but we'll be posting this slide after the presentation video has been uploaded. And here I've included a link to a blog post by my colleague who wrote about this methodology. Here on the top is another missing street, but this time the street is also missing from the imagery. And this is an example of an outdated imagery. Imagery is expensive to process and also expensive to acquire. And so by using probe density as guidance, we can first narrow down the regions where we should analyze the quality of our imagery, and then pick out the areas where we should focus our attention on to maximize the benefit of updating the imagery. From the density of traces, we can detect restrictions, such as one-ways and turn restrictions. And here on the top is an intersection where we found that in the weeks of traces we process, many people pass through this intersection, but no one makes these 4 turns shown in red. Now for this intersection, it's obvious from the geometry why people don't make these 4 turns. But for most intersections, you can't tell simply by looking at the geometry whether or not there's a restriction. And so we did this analysis for the entire San Francisco Bay Area and got a map like this shown on the bottom. And then we cross-checked the intersection shown in red with other sources, such as street-level imagery. We can also use trace density to calculate the lane center line. And here's a map of motorway lane center line. This kind of high precision trajectory map is useful for autonomous vehicle. From speed, bearing, and acceleration, we can get traffic information. And here's a traffic map. Most people are familiar with this map, but what most people don't know is that this map doesn't show you congestion. Congestion is the density of cars on the street, and this is currently something no one can measure at scale. And so what this map shows is how fast people are currently driving relative to how fast people typically go when the street is wide open. And this is a good proxy for congestion if people always drive as fast as they can. But you can think of examples where this is not true. For example, people slowing down to look for an address, or people slowing down to look for a parking spot. The same traffic information that goes into traffic map can be injected into a routing engine to get traffic-aware navigation system. And here on the left is a map showing the different routes that our traffic-aware directions API returns over the course of a day, depending on the traffic condition in downtown Toronto. Now, before I jump into how we actually got this information from telemetry data, I'd like to first show why we need traffic. Here's a comparison between 2 OSRM routing engines. One is powered by traffic, and one is not. And the y-axis is the estimated trip duration from this origin to destination in Paris. We monitored the 2 systems over 5 days, and as you can see, the traffic-aware OSRM returns a different ETA depending on the time of day, but the traffic-ignorant OSRM always returns the same ETA. And this is because without traffic, OSRM relies on a rule-based profile called the Lua profile, which estimates the traffic condition on the road based on OSM tags. And because OSM tags don't change from minute to minute, the resulting estimate is a static one. The disadvantage of this profile is it doesn't take into account how people actually use the roads. The advantage, though, is that it has 100% coverage. If there's a street in OpenStreetMap, there's a Lua estimate for its traffic condition. Now here I've overlaid our traffic profile on top of Lua profile. And as you can see, the traffic profile has a smaller coverage. The coverage actually fluctuates with time because this profile is computed from telemetry data, which reflects how people use the roads. But regardless of the amount of telemetry data we have, we can never get 100% coverage. This is because there are always roads that hardly anyone uses. Now, traffic in OSRM is present in the form of how much time it takes for people to flow from point A to point B. And one of the deciding factors is how fast people can go. And speed is something we can compute from telemetry data. And now, before we can jump in and start computing the speed probes, we need to first do some data cleaning. And as you can see in the map, the red traces are the raw anonymized pieces of traces, and they're very noisy. So what we do is we first feed them through a series of filters by distance, duration, bearing, etc. And at the end of this funnel, what we get are the white dots, which are the speed probes. And next, we match the probes to the road network. Now, we can analyze the traffic without doing this step, but if we do this matching, we have better signal-to-noise ratio. And so let's take this black trace as an example. As you can see on the top, the speed probe is the midpoint between the two location probes. So what we first do is we draw a circle around the speed probe and look for all the streets that are within the circle. And here we have 3 candidates. Next, we compare the bearing of the street to the bearing of the trace at this point and eliminate the road that has a very different bearing. And so you can see how a street is traced in OSM has an impact on how many probes can get matched to the street and whether or not we can compute a speed for it. So we're down to these 2 candidates. Instead of picking the street that is closer to the speed probe, what we decided to do is pick a street that ranks higher up in this road class hierarchy. And we designed this hierarchy based on road usage. 2 ways to think about this is, first, say if you have a motorway and a tertiary road as your 2 candidates, and without knowing anything else, if you're going to take a wild guess at which street this probe came from, the chance of you getting it right is higher if you pick the motorway. And the second way to look at this is any probe that is matched to the correct street is a signal, and any probe matched to the incorrect street is a noise for the street. And because a lot more people use the motorway, it has a very strong signal, and therefore it's more noise resistant. So for our example, the street to the north is an alley, and therefore, even though it's slightly closer, we still match it to the tertiary road to the south. So now we found the street. Next, we need to decide which part of the street we assign this probe to, as in, what is the smallest unit of a road that we use to bucket the probes. If we look at the map, the OSM way is very long. It's highlighted in red in the picture on the top. It extends over many intersections. And so if we were to take OSM way as the smallest unit for bucketing probes, what we're assuming is that whatever happens in this block at this moment has an impact on the traffic a few blocks down the road at the same instance in time. And this is most likely not true. We can also take OSM segment as the smallest unit of road to bucket the probes. But as you can see, the intersection at Front Street in California, there are these tiny segments that are so small that hardly any probes can get matched to them. And so what we decided to do is to create normalized ways. A normalized way is one that starts from one intersection and ends in the next. And the idea behind them is that once you've entered the normalized way, there's only one exit for you to get out. And so what we needed to do to this OSM way to normalize it is to cut it at the 2 intersections. And then for the tiny leftover piece at the end, we can join that with the next OSM way. And the resulting graph looks like this. And just to give you an idea, this is how many merges and splits we need to do to the OSM ways in San Francisco to normalize the graph. The orange dots are where we split an OSM way, and the green dots are where we join two OSM ways. So now we have the buckets, and we can start accumulating probes. And after a period of time, we can plot the probes in a histogram like this, where the bar height is the number of times we observe a certain speed. And now this histogram is not for the normalized way in our previous example, but for another normalized way. And you can see that there are some outliers at the two ends. Those are still due to the leftover noise in our traces. But even if we remove those, the remaining histogram is still quite broad. And now OSRM can only handle one speed per way. It cannot handle a range of speeds. So we have to pick something from this histogram to report. And here we decided to make use of our knowledge of the road class again. So if this were the histogram of a motorway or trunk road, we report something slightly higher. And if this were for a primary, secondary, or tertiary road, we report something in the middle. And if this were for an alleyway or a service road, because we don't want to route people onto these roads, we deliberately pick a slow speed. So the traffic profile in the end is a very subjective one. It's not what really happened in the real world, but rather what we want the routing engine to think happened in the real world. So all that processing in the end gets us this. A normalized graph with one speed per normalized way. But now OSRM does not use the normalized graph. OSRM uses what's known as an edge-based graph, where every road is a node in the graph, and every possible maneuver from one street to another at an intersection is an edge in the graph. So in order to load the speeds into OSRM, what we decided to do is at the end of speed calculation, we explode the normalized graph back down into OSM segments. So all the segments that make up a normalized way is assigned the same speed. And then OSRM can read in these segments and apply the speeds to the relevant edges in the edge-based graph. And we not only do this for the speed stack and OSRM, but any other stack that's part of traffic or other stacks that use telemetry data to use the information from one stack in another. The information is always conveyed via OSM segment. So in a way, OSM is like the translator between our different stacks. And I'd like to end my presentation here with this flow chart that shows how information flows between OSM, telemetry, and OSRM. And with this, I'd like to open up for questions.
Hi, thanks for the talk. That's quite impressive. When you talk about when you match the prop into the road network and you extract the speed from that, I'm just wondering, do you have anything like ground truth that you can check how accurate your algorithm or how accurate your method when you match your prop into the street, and how accurate is the speed profile you get from this kind of data? Thanks.
So there's actually not a ground truth to all this. Everyone drives at a different speed. Every car is different. And so we can get a general idea of how fast people should typically go. For example, if we get a 160 kph probe on an alley, that's definitely not right. But then we cannot say whether like 10 kph is wrong or 5 kph is right. That's something that's not possible. So, yeah, the traffic profile is not only subjective, it doesn't have a ground truth that we can verify. And so to correct for the model, all the feedback actually comes from OSRM. We put it into a routing engine, and then we test the different routes and see, like, for a long distance trip, are we getting something reasonable? If not, then why not? Does that answer your question?
Yeah, thanks.
So just adding like onto what he asked. So one question is, do you feed this like the computed speed profiles back into like OSM in some ways? Like, do we have this data? Second question is, like, do you measure, for example, like I know you're tracking ETAs, error percentiles, right? Do you, I don't know, look at aggregate, like for example, there are a lot of assumptions here, right? That you use the road types very heavily. Now, what if the road types in OSM itself is incorrect? Like maybe the service, something that's marked as a service road is actually not a service road, right? So like just wondering how do you kind of feed this data back, or if you feed this data back, and like is the result from all this actually accessible somewhere where we can try using the speed profiles you've computed for every road segment?
Yeah, so Mapbox is ready to give back to OSM any information we can. But traffic is not a type of information OSM can handle because it's very subjective and there's no ground truth. OSM can only take something that has a definite right or wrong. And so that's why we don't actually put the speeds back into OSM. And as for whether the tagging is right and not, this is actually something we do feed back into OSM, and it's through our data team that we edit the streets that are incorrect. And of course, before they edit, they have to double check all the sources they have, like street level and different kinds, to verify that what we're detecting is actually what's happening, and it's the tag in OSM that is incorrect.
There was a question. 前の方お願いします。
Hello. Do you, I missed the first minutes of your talk, so excuse me if you've said that already, but are you using this data to also capture live traffic events, like, okay, there's congestion somewhere, currently there's congestion somewhere, so let's have a better live routing? Because I remember that the OSRM team has recently announced their multi-level Dijkstra algorithm to be able to have quick traffic updates to the routing graph. So that would put you in a position to actually say, okay, don't take this road at the moment because there's congestion. Are you doing that already?
Yes, we are. We do have a separate stack from what I explained, but it works very similarly. But it only handles the data that's coming in, the freshest data coming in.
One more question. So in one of the earlier slides where you describe your data structure, so you get X, Y, Z, and T, right? Do you use elevation in any way?
Currently, we don't, just because the accuracy of elevation is not as good as the X and the Y.
Are you planning to integrate opening hours of streets or seasonal openings, passes, mountain passes and things like this into your OSRM database?
So OSRM actually parses that information from OSM. And that is something we can sort of detect with telemetry data from the absence of data. But yeah, we currently don't add anything back in that form into OSM. Just because when you detect something from the absence, there's also always like a higher rate of false positive, so that requires more checking. And also it requires a lot more data to support that you found disclosure.
Other questions? Since I'm just had another question. Do you feed back this internally to your data team, this absence of data, or if you have a road type and you detect an obvious error in OpenStreetMap?
The turn restriction, like I showed in the map, that's something that we detect, and we do give those to the data team, and data team checks over all the red intersections to make sure our prediction is correct before adding it into OSM. So we are feeding back. Yeah.
The question. Yeah.
So when you predict the congestion of the road, it may be depend on the actual density of the car. So in the city area, there are many cars that easy to predict, but it may be difficult to the non-density population areas like Aizawa Kamatsu. Do you have any threshold or the guidelines when you can predict congestion or not? I mean, so city size or the number of the car per hour or something.
Yeah, so currently city size is not included in our analysis. And part of the reason is that it's already reflected in how fast people can travel. In a very dense city, people are already traveling slower because of the number of people using the roads. So there is some redundancy in incorporating that data. And because of the large volume of data we need to process, this is currently not included. Like the benefit we get from including the population, for example, it's not as, I wouldn't say marginal, but then at this point, like we think there are other things that we can incorporate that can create a better traffic profile.
Any other question? Okay. Thank you very much. Next is today's last session, and OpenStreetMap Carto by Mr. Paul Norman. After the last session, we have the closing plenary in this room. After this session, many people come to this hall, so please share the sheet for the other attendees. Thank you.
Okay. So I'm Paul Norman. I'm one of the developers and maintainers of OpenStreetMap Carto. So what is OpenStreetMap Carto? It is the default style sheet on OpenStreetMap.org. When you go to the front page, most of it is OpenStreetMap Carto. The top and side is part of the website, but the map itself is generated using our style sheet. It's not the only option. There are other ones on OpenStreetMap.org. There's CycleMap, TransportMap, and Humanitarian, but it's in many ways not it's what people think of when they look at OSM. So, some history about it. The project was started, I guess, 5 years ago now, replacing existing XML-based style sheets that were used on OSM.org. I'm not going to go over the history from back then. There's a talk by Andy Allen that goes over 2006 to then, which he gave a few years back. But the more recent history. But it's a unique style sheet. It's the biggest open style sheet. It's the biggest style using OpenStreetMap, and it's the widest range of features shown. Just looking at it, you can see it shows a lot of stuff that no other map shows. One of its purposes is to show off OpenStreetMap data and the depth of that data. And that's why it is the biggest and most complicated style sheet. But that brings its set of challenges, and I'll get to those challenges later. It's also not a centrally managed style in that a project manager dictates what people are going to work on. The priorities for what to work on are set by everyone who is contributing. They work on what they're interested in. And this means that we don't necessarily know what direction it's going to go in the future. It depends what we want to do. It also is quite an innovative style in that we've introduced both cartographic and technical features that have been picked up by others and are now widely used. So we managed to get a release out every month or so. We have about 300 or 400 open issues, and this has been true for years, but they're not the same issues we had years ago. We close issues at a reasonable rate, but we find new ones. And yeah, there's about half a dozen of us who regularly contribute. So it's a very active project. Just briefly, there's a few components. This is the basic rendering stack. And the ones that that OpenStreetMap Carto is the style files, the MML and MSS, and the map that you get out at the end. Everything else is a different talk. There's a few other things we're not. Some people view the style sheet as a way to introduce new tagging, or the primary force that decides what gets mapped. And we've looked at some of the numbers, and this isn't actually true. The people mapping some sort of feature does not really depend on if it is shown on the default map or not. This came as a bit of a surprise to us, but the numbers are pretty clear. It's other things that matter more. Editor presets are a big one. We also aren't the only OpenStreetMap map. None of us think that. We are one of many, and many of us actually work on multiple OpenStreetMap maps. I've been the maintainer of 4 or 5 other styles. Unfortunately, we're not an easy project to keep up with because we are quite active. We have a fair amount of traffic on our GitHub repository with the issues and with changes, and it can get a bit overwhelming, even for me. We're also not responsible for the data. That's the OpenStreetMap community. The goal of the style is to take that data and style it. So some of the innovative things we've done. Automation is common with programming projects. So you've got code, you have tests for it, you automatically run those tests. It's not something that's common for map styles, but Carto CSS, the language that our project is written in, is compiled. So we have set up continuous integration that tests if it compiles correctly. It tests that some basic things that it is saying. Unfortunately, we don't have visual tests automatically. This has been something that many people would like. Across many styles, many people have looked at it. It's not easy. But our tests do work. They do catch mistakes that otherwise might make it into the code, so they're good. One innovation I've been partly responsible for is selecting colors. So if you've seen the map, it's got a lot of colors, about 200 in total. And a general principle is that similar features should have some similarities. So in this picture, which you can't really see well on the projector, you've got retail, residential, and industrial land use. So in this case, you want them to all have about the same lightness, and then you just vary the color and the intensity of the color. And that's a general cartographic principle, but we've applied, we've looked at this a lot more systematically in doing this, including with numbers. And the way we work with numbers is not working in red, green, and blue, because it doesn't work well for numbers. We use a different color space called LCH, which is lightness, chroma, which is how intense a color is, and hue, which is it red, is it green, blue? And the nice thing about this is that you can do math on it. You can look at two colors, and you can say, these two colors are too close apart to distinguish. And you can do that, say, when you've got 6 colors and you're trying to pick 6 features and you want a different color for each of them, and you want none of them too close to each other. That would be a lot of combinations to look at and evaluate by hand or by eye. Instead, you can put them into a spreadsheet and say, if I've got these two are too close, and check all of them at once, which means that you can then rule out a lot of things and say, I should test this and see how it looks on the map. And you spend a lot less time panning around trying to find things that look too similar. The other big thing is that you can pick 2 colors that have the same brightness or lightness. And you do a lot of that in cartography. You want 2 colors that, like the example before, different colors, but when you move the eye from one to another, one doesn't appear brighter than the other. It also enables us to do stuff like programmatic colors. If you tag OpenStreetMap roads, you know there are a lot of classes of roads. There's 7. And because some of them are white, we need 5 colors for all of the roads, or 6 counting white. These colors need to fit with each other. If you know the old map style, it started with motorways that were blue, trunks that were green, primary was red, secondary was orange, and tertiary was yellow. And the progression of colors, if you just looked at those colors, they don't form any sort of logical progression. If you look at the current colors, they go from a red through to a yellow to a white. And if I gave you cards with just those colors, you could put them into an order that everyone would probably come up with the same order. That's an important thing. But what it means is that you have to, again, testing lots of colors. So what we did is this was for a Google Summer of Code project, and as part of that, the student wrote a script that you take your start color and your end color, so your color for motorway and your color for secondary or tertiary, and it computes the colors between them and writes it out to a file, and you can then just change the endpoints and generate that file and try different colors, see if you can squeeze in one more color into that interval and still have them be possible to tell them apart. You can't. And you end up testing a lot more possibilities much quicker, which means that you can find the good ones much quicker. But enough about colors. One of the, this is a behind-the-scenes change. One of the most talked about things with it is something called that gets called HStore. It's been a schema change to the database that we're using to power the style. It took over a year to develop. All of us are volunteers, so it's when we're interested, when we have time. And it reduced the number of columns in the database, but added a column with a key value store. Did a few other things, but that's the change that will impact the look of the map the most. And yeah, it was a lot of work, but it will allow some new things, which I'll get to later on. I've learned a lot about fonts. I've learned too much about fonts. Most maps don't look at all languages. They just, and I'll be honest here, most look at just English or just English and other European languages that use pretty much the same alphabet. OpenStreetMap Carto, as a policy decision, we render the local name, the value of the name tag, which could be in English, it could be in Japanese, or it could be in a complicated language like Burmese, which is a very complicated language. And we had two big efforts at trying to get all the languages right. We've found bugs in Mapnik, which is the software that renders the map. We've found bugs in the fonts. You don't normally think of fonts as a source of bugs, but turns out when you get to some of these languages, they are. And some other pieces of the software for placing fonts. We're pretty happy with what we've got. We've had to, because all of us, our native languages are something that uses the Latin alphabet, so English or Dutch or something similar. We've reached out to the community looking for people who speak, Japanese, Chinese, Korean, Southeast Asian languages, and obscure languages, to see what fonts do we want to use, what fonts work well, finding bugs. Something we learned is there's a few lessons that we got about it. Letters are not what you'd expect. In Burmese, you can add an accent to a letter, which makes it taller. You can then add another accent to that letter, which makes it even taller. And you can repeat that indefinitely. As a practical matter, you probably would only do that maybe 3 or 4 times, but it does mean that with, again, English or Japanese, most of the characters are the same height. You get to these languages, and most are that height, but then some of them are really tall. We've had to accept that we're not going to get everything right. The problem is the text can conflict with labels, and if you give it too much space, it's a problem because your eye doesn't associate the two together. But if you don't give it enough space, you cut off letters. The other thing that I've learned is hand unification is terrible for us. It's interesting to be giving this talk in Japan because it's one of the languages, Japanese is one of the languages affected by hand unification. And that has been a real challenge. Another innovation has been how we've done land use labels. If you look back at if you look back to printed maps, it's common to change the size of your label based on the importance or the size of what it's labeling. So a small lake might have a really small label to fit it in, but a big lake can have a bigger label because the big lake is also probably more important. Web maps historically have not done this at all. We did a big change where we did a bunch of other label improvements, but this was one of the big ones, that label sizes became larger for things that are larger. And that's larger on the screen, so as you zoom in, the label might increase in size as well. And it has been a huge improvement that I have seen taken up by other maps, and I have used in some of my other projects. We've faced a bunch of challenges. We are, in many ways, pushing the edges of open source cartography. We, in a way that no other projects are. I wish there were more projects doing this kind of stuff. It would be nice to be able to look at other projects and take lessons from them. One of the challenges, this is sort of a conceptual challenge in a way, is hand unification. When you look at the name that you're of something in OpenStreetMap, all you know is the characters in that name, or in Unicode terms, the code points. You don't know what language it's in. This isn't a problem when it comes to Latin languages, which means the languages that the people who wrote the standard for how you encode text, those are the languages that they spoke when they wrote it. An English E is a French E. There's two different ways to write an A, but they're pretty interchangeable. This is not true for Chinese, Japanese, and Korean, as I'm sure everyone in the audience who writes one of those languages knows. You have what is to the computer, and the Unicode standard, the same letter gets written in different ways for each language. Unfortunately, we're not going to be able to solve this. It's something outside the style sheet that, unless someone comes up with an innovative approach, is just going to remain an issue, and we can't get it perfect. We are going to have what looks like the wrong characters for one of the countries. I wish it were otherwise, but we have to stay focused on what we're doing, because otherwise there's just too much stuff. A bigger challenge, one that's more style specific, is the rural-urban divide. We're in a fairly rural area for this conference, but it's still urbanized. And the cartography that you would use in a farmland area with farmland is not necessarily what you want in downtown Tokyo. Features are a lot denser in urban areas generally. So a point of interest, say a convenience store or some other kind of store, that might be hugely important in a rural area because it's the only one around for kilometers. You would want to show that fairly soon on the map. On the other hand, in downtown Tokyo, it's crowded in with a whole bunch of other stores, so you don't want to show it as soon. And for technical reasons, we can't do that right now. We have to pick one style, one choice of when to start rendering stuff, no matter where it is. We also don't have good data on what rural and urban is, which prevents making progress on that. We're not the only ones to have that problem. It's a general problem. But we do have some problems specific to our style. The way we deal with design decisions is as they come up, which is on a piece-by-piece basis. This is one of the things that has let us move quickly and come up with innovations. But are we moving too quickly? Are we getting out in front of what we can consider and moving in different conflicting directions with different changes. There's not a great answer to this, and we've been discussing this a lot lately. Do we need to slow down the changes and come up with a vision? The problem with that is that coming up with the vision will make it slower to develop stuff, but give us a better direction for what we are developing. I don't know what the answer is here. Among the maintainers, we have different opinions on what we should do here. Everyone wants to see what they've done on the map. They want to see what is of interest to them. So for someone who is interested in railways, they might want particular features about switches and stuff like that. But we can't render everything. We can't fit it all on the map. Part of cartography is making choices about what to render and what not to render, and choosing, no, this is not something we want on what is a general purpose map. We're not great about saying no. At least I feel we're not great about saying no. Other people who have had us say no, may feel otherwise, but it's a difficult decision. The style used to render a lot less than it does now. Do we need to cut back on some of the stuff that we're rendering? Should we add more stuff? There are problems either way. It's a challenge unique to OpenStreetMap Carto because no one else renders as much as we do. So what's upcoming? What are you going to see in the next year or so in the style? Well, I don't know. It's what people want to work on. So there is no grand roadmap of this is what we're going to have done in 3 months, this is what we're going to have done in 6 months. We're all volunteers, so we don't know what resources we're going to have, and we're going to work on what interests us. But there are still some things I can say. The road layers on an OpenStreetMap style tend to be complicated to write. They are about a third of our style. Our road layers, the code that generates them, is bigger than most other styles in total. Complete styles are smaller than our road layers. They're complicated. I don't understand them fully. None of us do. And when they were written, they were written in 2007 and then in 2012. And since then, people have discovered better ways to write road layers, ways that are simpler, easier to understand. And one thing I'd like to do is implement those ways in the style, which will make it a lot simpler. Something recent that has come up that has just made it into the style about this weekend, but not yet been released, is refinements from secondary tags. So one of them is better with the HStore and the schema change. We can now use more tags, so we can better select what's important. When you used to look at the map, you could see airports everywhere. So Kansas was a great example of this. It's a state in the US that is mainly farmland, and it had 50, 100 airports in it. These were little grass strips that are less than 100 meters long. They're not very important. The problem was we couldn't distinguish between those airports and big international airports like the ones in Tokyo. But now we can do that. So now we can pick what we want to display better. Another thing that we can do with these other tags is we can refine how we display something. So in this example, which I've shown here, when you map a forest in OSM, you can say what type of tree it is. So right now, the way forests are shown is with pairs of trees. One represents a tree that has broadleafs, so like a fruit tree, for example. The other is ones that generally coniferous, so pine, cedar, that kind of tree. So what we've had is just paired icons, one of each type. What we now will have is, for ones that are all broadleafed, we will have just that type of icon, and ones with other types, just that type of icon, and where it's mixed, we'll show a mix. So this is something that was not possible before, and will make us one of the better general purpose maps for the rendering of OSM forest data, and show off more of what the data in OSM is. We need you. So how can you get involved? We work on GitHub. Everything is on GitHub, and what can you do? You can report bugs. So if the data is correct, but the map isn't, then that is probably, that could be a bug in the style. And you can report that on GitHub. Other things that you can do and get more involved in is we do pull requests to do changes. So you can help by testing those. You can run the style locally, look at your area and test. Does this pull request improve the map? Is it better with it? You can, and if you have trouble with that, you can ask for help. If there's documentation problems, you can't figure out the documentation, you can ask for help. You can also make your own pull requests. A lot of people who have learned Carto CSS, the language which the style is written, have really developed their knowledge of the language on OpenStreetMap Carto, because we're one of the projects where we have more than one developer. When you get stuck, you can ask someone else. We do code review. We can look over the code. We can suggest ways to improve. And with that, I'll encourage you to take part and open it up to questions.
Is there any question? Are there any questions? Okay.
Hi, Paul. Does OpenStreetMap Carto team has any mission statement or target audience or anything?
We have the closest to that is what the style is and the purpose of it, which, and I'm going from memory here, is to show off OpenStreetMap data, to be a style that others can customize for their use, to be a general purpose map from OpenStreetMap, and a couple of others. And sometimes these pull in different directions. So this is often a problem that comes up, is that there are things that we would like to do and we could write the code to do, but are too complicated, particularly too complicated for others who aren't involved in the style to understand. The same with showing off OpenStreetMap data and good cartography. We see this in the number of features to render. And in a way, it would show off more OpenStreetMap data if we just rendered more features. But it wouldn't look very good, so it wouldn't show it off in terms of having good cartography. We don't have a mission statement for where we are trying to go with the style. that is done on a more decision-by-decision basis.
Have you thought about generalization?
Yes. Generalization is taking OpenStreetMap data and then processing it in some way to, say, simplify it, generally so that you can use it at a lower zoom. And one of our goals, so one of the goals of the style is to use only OpenStreetMap data and to allow a frequent update cycle. So on OpenStreetMap.org, it takes 30 to 90 seconds typically from the time you upload a change for it to be on the map. You might have to hit reload, there's caches and stuff like that. And generalization is really hard with updates like that. We are using, in a way, the coastline is generalized data, and that updates every day. Same with the Antarctic ice sheet data. That also has to rely on special generalization, generalization-like code, and that also only updates every day. Real generalization can do a lot of useful things. We could get better coastline at low zoom. We could, if you look at the map in areas where there are a lot of small lakes, it doesn't look great. We could do better lakes there. The problem is that these generalizations need someone to run them and maintain them and run them regularly. And we don't see our role as doing that. Those often also require specialist knowledge to develop in those fields. So the ice sheet generalization was developed by someone who maps a great deal in the Arctic and Antarctic, and there's details there that I don't know anything about. There are some things that I would like to use generalizations for, such as right now, rural versus urban areas. We use a shapefile for that that's about 30 or 40 years old. And it would be nice to generate it from OpenStreetMap data. And a number of people have looked at ways to do that. And no one has found a good way yet. When someone does find a good way, we will probably use it. There's also generalizations such as turning a motorway that is split into a single line at lower zooms. It would be nice to do that. We haven't really none of us have really looked at it. It's, again, something that's fairly tricky to do with the technical infrastructure that the style has to deal with. It's much easier to do, it is a lot easier to do many of these things if you just take the entire planet and process it and don't have to worry about updating it every minute. That is the big problem with generalization.
Okay, Paul, it's the time to next
stage.
Thank you very much for Paul Norman.
Oh, I will probably be talking with people about Carto stuff sometime tomorrow in one of the sessions. So just look for me.
Thank you very much. Let's get the tomorrow's session. And then this next program is a closing plenary. So every attendee come to this room. So please share the sheet for every attendee participant. Everyone, please sit on that. Please sit on the hall. 席を譲り合っていただけますようお願いします。 すいません、ボランティアの方、マイク前の方へ持ってきてください。お願いします。会場のワイヤレスマイク前の方に持ってきてください。お願いします。
Hello? This one works. Hello, everyone. So this is our closing plenary. It might be confusing because we do have an extra day tomorrow of workshops and some more discussions. But this kind of ends the start of our main talks and the last day that we have this big room. So we're making use of it for, I've got 3 exciting notices to talk about. I'm Gregory, and so I'm on the organising committee of State of the Map. It takes a good year to organise the conference, and it's all volunteers that organise it. So volunteers that they're taking time off work and paying for their trips to come here. So it's quite a commitment, but we have a big team. First of all, I want to, so in fact, actually, on page 20 and 21, it's taken 2 pages to thank the people that have helped over the year and on the 3 days of the conference. I want to particularly thank Mikel Marin and Benoit Fournier. They have been really helpful on the committee, and they're not even here because they couldn't make it. So I'm sure they've been watching the video, and I'd like to thank them. I want to thank Rob, who's hiding over there and taking a rest sitting down, because he leads our global team, and he puts a lot of work into it, especially this year, while having a job that isn't about OpenStreetMap. So his employer probably wonders if he's working another job, because all his lunch times, it seems, all his evenings are organising this conference. So there's a lot that goes into work, sort of organising our sponsors, making sure we've got the equipment to live stream, to talk, to show you the banners. But a lot of that is helped by the local team, and the team that have served us well by providing us drinks and lunch and showing us where to go. So if you're a volunteer, I'd like to invite you all to come up to the stage so we can just see that you helped. So maybe you need to translate. The volunteer team. And Kinya and Jun, you also come up because you've led this team very well. So we want to see you. So you can see it's not a small team that is needed for this conference.
Everybody, thank you very much. Welcome to Fukushima and Japan. We are so happy and may enjoy in Fukushima. Thank you.
Oh, do you want to?
So yeah, now it's my chance just to say something really shortly as well. This is always a bit of an emotional speech to me, to be honest. But Kinya, who's been my personal contact between the remote team and the local team over the last year, he said to me when I arrived, he said he's very happy and proud to see so many people have traveled so far. It got me thinking about that word, proud. I think to me that sums up everything about OpenStreetMap and the State of the Map group. And I just want to say I'm so proud to have worked with you over the last year. So thank you, Ikia. Thank you.
So let me see mine. So that's the team that helped this year's State of the Map. As I said, it takes a whole year, a good year of planning this, and so that means we probably need to get started on next year's. You're probably excited maybe to start thinking about it and convincing your employer to send you to State of the Map 2018 or saving up the money so you can send yourself there. And if I find... So you may have noticed during the breaks I've had this date up. I want to say that the process for the State of the Map, where we go each year, we ask the community and the local groups to put in a bid and say, we have a local team, we have local people, we want to invite you to come, the international community to come. So for 2018, we had 2 amazing bids, which made it very tricky. There were discussions going that they were both very good. And so we had a great bid from Heidelberg in Germany that I think it could have been a great conference, and I think they may even think about a conference in the future. But we have chosen the venue of 2018 that was slightly further ahead on what we want. So we have the dates there booked, and I'm hoping he's in the room. I'm going to ask Marco to come up and tell us where it is, which means you may guess from his accent when he starts speaking. So Marco, you have the honor, because I imagine there's some people waiting to hear. I choose my holiday based on where State of the Map is each year.
Well, the candidates were just two, so it's not Heidelberg, so it will be Milan, in Italy. So, just a couple of more words. The conference will be jointly organized by two organizations, so Wikimedia Italia and the Politecnico di Milano. Wikimedia Italia is the OSM local chapter, Italian local chapter. Actually, it is also the Wikimedia, the Italian local chapter of the Wikimedia Foundation. Since last year, it is also the Italian OSM local chapter. And Politecnico di Milano is the university where I work, and well, we are the top-ranked Italian university. We are one of the best in Europe, and I think among the best 200 in the world, according to the latest ranking. And most of all, we have a very active local community. We have some members of the community in the audience, and it's since 2009 that we have the local Italian OSM conference that is called OSM IT, or OSMIT, as we pronounce it. So, well, we are very, very happy and very proud to host this event. Some words about Milan. Well, you know, the capital of Italy is Rome, but Milan is said to be the economic capital of Italy, or the fashion capital of Italy. It's in the north, and it's very close to the Alps. It's very close to the beautiful lakes that you have in the north of Italy, Lake Garda, Lake Como, Lake Maggiore, and so on. It's just 1 hour and a half by train to Florence, say 2 hours and a half to Venice. So I would say well located, and so nice idea for attending the conference and for taking a trip to Italy, which is wonderful, but I'm sure you already know. And so what else? So I would like to thank the OSM Foundation on behalf of all the organizing team, Politecnico di Milano, Wikimedia Italia, and all the OSM Italian community for trusting us and our proposal. And, well, I'm looking forward to meeting you all in 1 year in Milan. Thank you. Should I stay?
So yeah, 2018. We hope to see a lot of you there and some other people. And yeah, sounds like a great place. So the last thing to talk about today, well, not the last thing to talk about today. I'm sure we've got lots of things we want to talk about to each other. So the social event this evening is a great opportunity to keep these conversations going, to talk to maybe some of the speakers that you didn't get a chance to ask questions. There will be food there, and I'm aware some of you are vegetarians, which, if you're Japanese, is not great, might be interesting. The name badges, the team have some yellow ones, and if you're a vegetarian, if you change, instead of being red, if you get a yellow one, will they be on the welcome desk? On the welcome desk, yes. So outside on the welcome desk, you can pick up a yellow one instead. Inya has them in his hand, and that means you can, the staff, yeah. So the staff can see that you've got a yellow badge, and they'll give you some vegetarian food rather than some meat food, which seems like a great system. If I leave them here, people can pick them up. So yeah, that's at 6 p.m., so in a short while at the Castle Hall, which I'm sure we'll all walk around there soon. Thank you. Have we got books?
Super. We're doing a donation box. Hopefully Dorothy's got that. Have you got that? She's looking at. It's on the desk. Okay, that'd be great. So there'll be a donation box, which Dorothy is just about to bring in. Do we have? We do have a bit of time. Super. And all proceeds will go to the OpenStreetMap Foundation in Japan, so the local team. So if you want to make a small contribution, you're more than welcome to. That was it. I forgot to remind her, that's why she wasn't prepared. But we'll just give her a second. You're free to go, everyone.